This Faceless YouTube channel, it's making $38,000 per month from Google AdSense alone with over 5 million views. And I'm about to show you exactly how to copy their entire system using AI automation. So take a look at this. This is Motiversity, a motivational content channel that posts almost daily inspirational videos, and it's generating serious revenue with a completely automated approach most people think is impossible to replicate. And here's what's crazy. I just built an AI system using N8N that can create these exact same long-form YouTube videos hourly, handling everything from generating video ideas and writing prompts to creating those visuals, adding voiceovers, and even uploading to YouTube completely hands-free. So while other creators are spending hours editing single videos, this automation workflow generates professional content 24/7. And I can hear you thinking already, you're probably wondering, how does a no-code tool actually create videos that look this polished? How do you set up the AI to generate ideas that actually get views? Most importantly, how do you automate the entire process so it runs without you having to touch it? I'm gonna walk you through the exact system that I built, the same workflow that took me from manually creating videos to having an AI agent that produces and publishes content while I sleep. So that by the end of this video, you are going to have a complete blueprint to set up your own automated YouTube empire. Because what I'm going to show you isn't just theory, it's really a working system that's already generating results. I added the AI tools that we're going to use today in the description below, so you can go ahead and check it out too. All right, before we start breaking this down node by node, let's run the whole workflow so you can see the end result first. That way, once we go step by step, you'll already have the full picture of what we're building towards. Now, we're going to start in ChatGPT here, where I'll ask for a simple table of video topics. And this provides us a neatly structured list with titles, captions, and prompts. Now that's our raw material, the creative fuel for the workflow. And from there, I'll copy the table and paste it into Google Sheets. It might feel like a quick sidestep, but this part is crucial. We need to keep the data organized in Sheets so N8N can pull from it cleanly and reliably every single time. Once the sheet is ready, I'll flip back into N8N and hit execute workflow. And here's where it gets fun, because the entire pipeline kicks in automatically. Notice how there's no manual back and forth here. The nodes handle it all for us. Sheets, AI, JSON to video, YouTube, each one firing in sequence, passing the work to the next until the process is complete. And after that, let's head over to the YouTube channel. And there it is, the finished video already waiting in the uploads. Now, to double check, let's go ahead and play it back in a new window, and everything is exactly where it should be. What normally would take hours of manual editing and uploading just ran on its own in the background, turning raw ideas from ChatGPT into a fully published video. Now, you already know how the full workflow looks once it's running from end to end. So now let's make sure the essentials are set up before we try it ourselves. It only takes a moment, but without these, the automation won't get very far. First, we'll have our chat model credentials ready. And in this case, it's with Gemini. That's what authenticates the AI so it can generate the responses driving our workflow. Next, we'll set up Google Sheets credentials, which give N8N direct access to store and retrieve the structured data we'll be working with. And lastly, we will prepare YouTube credentials, so once everything is generated and rendered, the workflow can upload videos straight to our channel automatically. So Gemini, Google Sheets, and YouTube are now all connected, which means we are now fully equipped to move from raw ideas to published videos, just like in that demo. And now it's time to start the workflow. The first thing we're going to do inside N8N is tell the workflow when to run. Instead of kicking it off manually each time, we'll schedule it to execute automatically on a consistent basis. To accomplish this, I'll click Add and search for Schedule Trigger. This node is what starts the workflow on a timed interval. Next, I'll change the trigger interval to hours, which defines how often the workflow will run. Now for this build, I'll set the hours between triggers to 1, so the workflow executes once every hour. Then I'll set the trigger at minute to 0, making sure it fires right at the top of the hour. And once that's in place, I'll execute the step to test it. And if everything is configured correctly, the trigger will fire and confirm that the workflow is now set to run automatically every hour on the dot. After setting the workflow to run on schedule, the next thing we'll do is connect it to a reliable source of ideas. And Google Sheets is going to serve as that source, giving the workflow structured rows to work with every time that it runs. And filtering for rows marked for production ensures that only fresh content is selected. And by pinning the data, we can speed up testing without constantly pulling from the sheet again. So let's set this up. I'm going to click Add and search for Google Sheets. Once the node is added, I'll set the operation to get rows, which tells the workflow to read from the sheet instead of writing to it. And from there, I'll authenticate the node by adding my Google Sheets credentials, which allows N8N to talk directly to my account. After establishing the connection, I'm going to configure the resource as sheet within document and keep the operation on get rows. Then I'll select the correct document and then point the node to sheet 1 inside that file. Now it's time to make sure that the workflow only pulls the right data. So I'll add a filter that looks at the column called production_status and only returns rows where the value is set to for production. Since we only want one row at a time to avoid duplicates, I'll also toggle on the option to return only the first matching row. And that ensures the workflow always has a single clean input to process. Now, before we can use this sheet though, we need to prepare the data structured inside it. So I'm going to go to ChatGPT and I'm going to ask it to generate a table with the necessary columns. And the table starts with an ID column that begins at 1. Then there's an idea column that contains a short YouTube title about the topic, a caption column for the video text, and a channel style prompt column where we expand on the channel keywords in 5 to 10 words. Next is a character style prompt column, which defines a unique visual character that matches the topic, followed by the production status column, which we always set as for production. There are a few other fields too: final output, which we leave blank, publishing status, which we always set as pending, and error log, which always stays blank. Once ChatGPT generates that table, I'm going to copy it directly into sheet 1 of the document so it's ready to be used by the workflow. Now back in N8N, I'm going to execute the step, which retrieves the row from Google Sheets. And lastly, I'll pin the data so I don't need to refetch from Sheets during testing. So from this point on, every time the workflow runs, it will have a structured production-ready row to work with. Now that the workflow can fetch ideas from our sheets, next challenge is turning those raw inputs into something structured and usable. Instead of jumping straight into rendering, we're first going to build a storyboard that maps out the entire video. We will use a LLM chain here so that the workflow can generate scene-by-scene directions, complete with narration, visuals, and style notes, giving us a clear framework before any assets are produced. So to build this, I'll add a basic LLM chain node in N8N. I'll set the prompt source to define below, which allows us to write the system instructions directly inside of the workflow. Then I'm going to map in the context variables from Sheets, the video title and the video description, so the AI has the right input to work with. In order to make sure the output is consistent, I'll toggle on the option that requires a specific output format, which forces the model to respond with structured data rather than just free text. Inside the chat messages section, I'll add a system message. This is where we guide the AI on how to behave. And for this workflow, I'll ask ChatGPT to generate a system message that frames the model as a YouTube content generator for dinosaur videos. The inputs will be the video title and video description pulled from our Google Sheets. Now, the task is to create a structured storyboard broken into 15 sequential scenes. And the storyboard follows a clear pattern here. The first 3 scenes act as the intro with a hook and setup. Scenes 4 through 11 build out the main educational storytelling. And then scenes 12 through 15 form the conclusion and the call to action. Each scene needs to contain a scene number, the voiceover text, a topic focus, a description of the visual style, a character prompt, and the type of audio that should be used. The output must be structured as an array of scenes only, without any extra explanation. Giving the AI strict formatting rules like this makes sure the storyboard comes back consistent and ready for the parser. Now I want to make editing easier, so let's expand the workspace using the expression arrow in the bottom right here and paste the system message there. Once that's in place, I'll return to the canvas and I'm going to add a chat model node, selecting Gemini as the engine and connecting it with my credentials. This is what powers the generation of the storyboard. After that, I'll drop in an output tool and choose the structured output parser. In order to make sure it behaves correctly, I'm going to ask ChatGPT to generate an example schema that includes all the fields we defined earlier: scene ID, the voiceover text and image prompt, the topic focus, and the audio style. Having that example in place guides the parser so that every scene the model generates fits into the same structure. Once the parser is connected, any storyboard that comes out of the LLM chain will be returned as clean machine-readable data. And that means the next steps in the workflow can reliably grab the text, the visuals, and the audio instructions without us worrying about inconsistent formatting. And now I can execute the workflow. The AI runs through the instructions, generates the 15-scene storyboard, and once it's finished, I'll pin the output. Pinning saves the storyboard so it can be reused for testing without regenerating new data every time. Alright, so music plays a big role in making videos feel polished. So the workflow needs a way to manage audio just as smoothly as it handles storyboards or visuals. And to accomplish that, we'll prepare a dedicated audio list inside a secondary sheet in Google Sheets. Now this list will hold references to the tracks we generate and then tie them back to each project. Setting it up ensures every video gets consistent background audio rather than relying on whatever happens to be available at the time. I'll begin by adding a new Google Sheets node in N8N and setting the operation to get rows, which allows the workflow to read existing rows. After authenticating with my Google Sheets credentials, I'll configure the resource as a sheet within document, point it to the same file we used earlier called topics, and then select sheet 2 instead of sheet 1. Now this sheet will be reserved exclusively for audio related data. Inside sheet 2, I'll create 4 new columns: audio list, to used, randomized audio, and intro video. Now these columns define where audio metadata and usage choices will be tracked. And structuring the sheet this way makes the workflow predictable and keeps all audio assets tied directly to the right project. Next, we'll prepare the actual tracks. On Suno.com, I'll click Create and then ask ChatGPT to generate a music prompt that matches the topic of the video. Once I have the prompt, I'll paste it into the Describe Your Song box here in Suno and then click Create to generate audio. The right panel will display the tracks, and from there we can use the 3-dot menu to download them as MP3 files. I'll repeat this process at least twice so we have multiple tracks ready, giving the workflow some options to choose from later on. Now that leaves us with a set of background tracks the workflow can either rotate through automatically or assign directly to a project whenever needed. And given this, the workflow has a consistent way to pull in background audio that can be randomized or assigned directly, ensuring that every generated video comes with music already baked in. Having the tracks downloaded is really only half the job, because for the workflow to actually use them, we need a way to host the files online and link them back to our project data. JSON to video gives us that hosting layer, letting us upload the MP3s and grab shareable URLs. But once the links are stored in Google Sheets, the workflow can reliably pull in the right audio whenever a new video is created. I'll start on jasontovideo.com by signing up for an account. And once inside, I'll go to my profile here. I'm going to open up the template section and I'm going to add a new template. This creates a dedicated space for the audio elements we're about to upload. Clicking into the new template opens up the editor, and from there, I'll move to the left-hand panel. Under movie elements here, I'm going to add a new element and select audio. Doing that creates the placeholder for our background music inside the template. On the right side here, under Assets, I'll click the pencil icon to open the audio asset editor. And from here, I'll go to Uploads and bring in both MP3 files that were generated earlier in Suno. Now, let's select one of the audio files and click Save, attaching it to the template. I'll then repeat the process for the second file, so both tracks are available inside JSON to video. So let's return to the Movie Elements panel here. Let's click Audio again and open the asset editor once more. This time, instead of uploading, I'm going to copy the URL for the hosted audio file. And that link is what makes the file accessible to the workflow later on. I'll paste the URL directly into our Google Sheets, specifically into the audio list column of Sheet 2, tying the track back to our project data. And I'm going to repeat the same process for the second file so that both tracks are properly linked. After doing all of these, we now have two audio files hosted on JSON to video, each with its own URL stored neatly in the sheet. Now this gives the workflow consistent, reusable access to background music for any video it produces. All right, so our audio is ready to go. So the next step is to enrich the project with a proper intro clip and set up a system for choosing background music. The intro video makes the final output look a lot more professional, while randomizing audio ensures that no two videos feel exactly the same. JSON to video is where we'll build the intro element, and Google Sheets will handle the logic for our music selection. Inside jsontovideo.com again, we will continue working inside the same template we use for audio. Under Scenes, I'll add a new element and select Video, which creates the placeholder for the intro. On the right-hand side again, under Assets, I'll open the video editor, switch to Pexels, and search for a stock clip related to the project topic. For example, dinosaurs. Once a clip is chosen, I'll save it over to the template. Then I'm going to open the asset editor again to copy the hosted URL. And that link goes into Sheet 2 of our Google Sheet, making the intro clip available to the workflow just like the audio files. Now, the second part of this step focuses on music randomization. In the To Use column of Sheet 2, I'll insert a formula that selects one audio file at random from the list. And this gives every video variation without manual input. After the formula runs, I'll mark the chosen track as final, so it becomes the audio file locked in for production. Back in N8N, we're going to open the Google Sheets node and then add a filter that only retrieves rows where the To Use column equals final. And this way, the workflow works only with the confirmed audio instead of pulling multiple tracks at once. And there you go. The project now has a hosted intro video tied directly to the sheet and a finalized audio track chosen automatically. And that combination ensures each video has both a professional opening and unique background music, while the workflow remains completely hands-off. At this point, the workflow has all the building blocks ready to go. A storyboard broken into scenes, captions, an intro video, and a finalized audio track. The goal now is to bring those pieces together inside JSON to video so that they form a complete rendered documentary. Rather than handling editing manually, this step packages everything into one request and then lets the platform do the assembly automatically. I'm going to start in the existing Google Sheets node here and narrow the input to the one audio track we finalized earlier. Now in the filter, I'll point the column to Use and set the value to final so only the confirmed background music is pulled into production. Next, we need to return to the canvas and add an HTTP request node that will talk directly to JSON to video. So I'm going to change the method to post here since we are creating a new render job. For the URL, let's open the JSON to video dashboard, go to the N8N tutorial, and grab the endpoint from how to configure your N8N nodes. Then we'll paste that address into the node so the request routes to the correct API. Authentication comes up next. I'll use generic credential type with head auth, create an entry named XAPI key, and paste in the API key from my JSON to video account or email. That header secures the request and lets the platform accept our job. So let's toggle send body to on, set the content type to JSON, and choose using fields below so the request can carry all the video parameters. Now I want to make editing easier, so let's open Expression and expand the workspace, which gives me room to work on a larger payload. Now, instead of writing it from scratch, I'm just going to ask ChatGPT to draft the JSON structure for this render job. Now, most importantly, it will include a clips section that maps all 15 storyboard scenes from the LLM chain, and each scene will have its voiceover text and image prompt aligned with the correct scene number. Once the generated payload is pasted into the node, all 15 scenes will be referenced. Doing this ensures that every part of the storyboard renders with its matching narration and visuals when the job runs. I'll paste the generated JSON into the node in N8N, locking in the full request so it's ready to send to JSON to video. Now, if a template hasn't been created yet, I'll just set one up in JSON to video first so it contains the elements the request expects: video, text, audio, image, voice text, and the movie elements we referenced earlier. Matching the template to the request fields ensures the payload drops neatly into place when the job runs. Next up, I'll customize the fields in the JSON body so they point to this exact template and to the data produced in earlier steps. The template name will be copied from the template URL after the template equals parameter. Now, the voice model will be set to Azure, and I'll choose a specific voice ID from the Azure Voices list. The image model will be set to Flux Schnell, and the audio URL will come from the randomized track in Google Sheets. The intro video will use the hosted link we grabbed from JSON to video. The intro text will pull from the caption in the topics row retrieved at the start. Now for the clips block, I'll map each scene's voice text and image prompt from the LLM chain output so every storyboard scene lines up correctly. And once the request is assembled, I'll execute the node. And JSON to video will receive the job and begin rendering. I'm going to pin the node output so I can reuse IDs and status info during testing without resending the entire request each time. Now to confirm the render is underway, I'll jump back into the JSON to video dashboard here. I'm going to open up render logs and check the most recent entry. And seeing the new job listed there tells me that the pipeline has moved from data preparation to full video creation exactly as planned. Video rendering inside JSON to video doesn't happen instantly, so the workflow does need a way to pause and then check whether the output is finished before moving forward. Now, this step introduces a delay and then loops through status requests until the platform confirms the video is ready. The safeguard here prevents the workflow from trying to use a file that hasn't even been processed yet. I'll begin by adding a wait node, which creates a short delay before sending the next request. Setting the interval to say 10 seconds gives JSON to video time to work while also avoiding unnecessary API calls. After that, I'm going to copy the previous HTTP request node, I'm going to paste it and adjust the settings instead of building a new one from scratch. We will change the method to GET since this request is about retrieving information rather than creating something new. I'm also going to update the configuration so it passes parameters instead of a JSON body. In the fields, I'll add one called project and drag it in the project ID value from the input. Now this makes sure the request always points to the correct job generated in the previous step. And once the node is ready, we'll execute it. JSON to video will return the status of the project, showing whether it's still processing or complete. And when the response includes a video URL, that confirms the rendering has finished successfully and that our workflow can move forward with a fully processed file. Status request is in place, but the workflow does still need a way to react differently depending on the result. A video might be finished, still rendering, or it could fail altogether. The switch node makes it possible to branch the workflow into clear paths for each of these outcomes, keeping the process reliable and easy to debug. I'll add a switch node here to the canvas, and I'm going to set up routing rules based on the status field returned from JSON to video. And the first rule checks whether the status is equal to done, the second rule looks for running, and the third rule flags error. These three options cover every possible response from our rendering process. And to make things easier to read later, I'll rename each output accordingly. Output 1 becomes done, output 2 becomes running, and output 3 becomes error. After the rules are in place, I'm going to execute the node to test it. And the workflow will then branch according to the project's current state, ensuring that completed videos move forward, jobs still in progress loop back to waiting, and errors can be caught without breaking the entire pipeline. Now, even with automation, some projects can fail or take longer than expected to render, and I want to keep the workflow stable. That's why we will add error handling and a loop for rechecking jobs that are still running. And that way, failures are tracked clearly in our Google Sheets, and ongoing processes are given more time without overwhelming the API. So to accomplish that, let's start by duplicating the existing Google Sheets node so that I can reuse its configuration. This duplicated node will connect to the error output of the switch node. And instead of retrieving rows, I'm going to change the method to update row. The target will be sheet 1, which is where project statuses are tracked. And in order to make sure the update goes to the right place, I'm going to set the column to match on the ID and pull that ID from the topic's input. For the new value, I'll set production status to error. And this way, whenever a project fails, the workflow immediately logs it in the sheet for visibility and tracking. And for the running output of the switch node, I'm going to add a wait node. This prevents the workflow from spamming the API while the project is still being processed. I'll set the interval to 10 seconds so checks are spaced out safely. After the wait, the workflow loops back into the get project HTTP node, sending another status request. And the cycle continues until the response shows the video is complete, at which point the workflow can move forward confidently. And after this, errors are recorded automatically and ongoing jobs are monitored in a controlled loop until they finish. And that keeps the entire process resilient and efficient. Once a video finishes rendering successfully, the last step is to record that completion in our Google Sheets. Updating the sheet keeps the project status accurate and adds the final video URL, so there's always a direct link back to the finished output. And this closes the loop and ensures that our workflow not only generates content, but also tracks it properly. So to do this, I'll duplicate the Google Sheets node again so the setup is already in place. This duplicate connects to the done output of the switch node, meaning it only runs when a project has been completed without errors. Inside the node, I'm going to change the production status column to done, which marks the project as finished. I'll also update the final output column here by pasting in the video URL returned from JSON to video. After executing the node, Google Sheets writes the updates immediately. And from that point on, the sheet reflects the current status and provides us with a clickable link to the generated video, making it easy to review, to share, and to publish. All right, so the last step is all about confirming the finished video can actually be accessed. So once JSON to video has generated the file and the URL is stored in our Google Sheets, the workflow makes a direct request to that link. Now, this quick check verifies the output is functional and retrieves the completed video asset. I'm gonna add an HTTP request node and set the method to get, since we are only fetching data rather than sending anything new. From the input section, I'm going to drag in the final video URL that was written into the sheet in the previous step. Now, executing the node sends a request to that link, and as soon as the video responds, we know the asset is available and ready to use. It's at this point that our workflow has officially carried a single idea all the way from concept to a finished accessible video. The workflow wouldn't feel complete unless the finished video actually makes its way into YouTube. Now, this step handles that final move, uploading the generated file directly to our channel, so the process runs end to end without any manual publishing. Setting the privacy to unlisted keeps things safe, giving you the chance to review the video before deciding to go public. So I'm going to begin by adding a YouTube node in N8N. And for the operation, I'll select Upload a Video, which is the action that pushes new files onto the channel. To authenticate, I'm going to connect my YouTube credentials so N8N can access my account. And once it is connected, I'm going to set the resource to video and confirm the operation is upload. The title field will also use the idea that came from the topics node, ensuring the uploaded video name matches the original concept. For region code, I'll select Philippines, though you can change this depending on your own location. The category will be set to film and animation so the video lands in the right section. As for the video file itself, I'm going to point to the binary data that was generated in the previous step. Now, to enrich the upload, I'll add some extra options. The first is description, which I'll set to the caption taken from the topics node. The second is privacy status, which I'll mark as unlisted so the video stays private until I'm ready to share it. And after everything is in place now, I'm going to execute the node. And the workflow will upload the file to YouTube with all of the specified metadata. So let's confirm if it worked. Let's head over to my channel's content section here and check my uploads. And the new video will appear there as unlisted, showing that the automation carried it all the way from storyboard to live content on YouTube. And that's it. You just saw how we can go from a simple idea in a spreadsheet to a finished YouTube video all uploaded automatically. I'll see you at the next one.